So in order to begin our studies of trigonometry, we're first going to have a quick look at the idea of congruence and similarity. Now, if two things are exactly the same shape and size, they're congruent, like these two cavemen guys over here. If two things are the same shape but different size, then they are similar, like these Russian dolls over here. I'm just going to show you how we can think about this in terms of similarity, in terms of transformations. So look, I'll just make a quick polygon here in GeoGebra. Now, if I was to just move that polygon around, okay, let's say I take that polygon, make a copy, and I move it around. Okay, if I move this shape around, a translation of this shape will, these two shapes are congruent. They're exactly the same shape and size. Okay, if I was to translate it, then we get a similar shape. Now, what about if I reflect it? If I take that shape and I reflect it in a line, well, let's draw a line first. There's a line. Okay, so now if I reflect my shape in that line, whoops, reflected it in its own edge. Take this shape, reflect it in this line, zoom out. Okay, now those two shapes are exactly the same shape and size. They do have a different orientation. Let's just make it a bit more extreme so we can see that. So these two shapes, this is the object, this is the image, and these two shapes are congruent. So translation and reflection give us a congruent image. Let's get rid of that. Okay, and let's have a look at rotation now. So if we take this shape and we rotate it around this point here, and we rotate it 45 degrees, okay, so I can take the object and its rotation, and they're always the same shape and size, so these two shapes are congruent. Okay, so of the four transformations, translation, rotation, and reflection all give us congruent shapes. However, there is one that gives us similar shapes. Let's have a look at that now. I'll just undo my rotation. Now, if I was to enlarge this shape by a certain scale factor, I'm going to get a congruent shape. Hold on one sec, so let me delete all this stuff. In fact, let's just start a new page, shall we? Okay, so we'll start by just constructing a polygon. Okay, and we're going to enlarge it. Dilation, it's called here. And first we'll plot a point down, and now we're going to take this shape and we're going to enlarge it around this. Okay, so select object to dilate, then the center point, and then enter the factor. So here's our shape, there's our center point, and the factor will go for a 2. So we're effectively enlarging it by a scale factor of 2. And we can see these are similar shapes. Okay, now similar shapes have certain properties which are useful and helpful when solving properties. And the first of those is obvious. If they're the same shape, then they must have the same angles. Okay, let's just show a few angles. So select 3 points or 2 lines. Let's go for these 2 lines here. 1, 2, 3. Okay, that's not what we wanted. Let's try again. Let's try going click, click, click. There we go, that's the one we wanted. And you can see that angle there is 43.49. If we do the same over here, 43.49. Okay, and it doesn't matter what happens to the enlargement, whether we move the center of enlargement, whether we change the scale factor, that also doesn't matter. Those two angles will always be the same. And they would be the same for any angle in the shape. (48.62), and obviously the sum of angles in a triangle is 180, so if these two are the same, this one here must also be the same. Okay, so what we're seeing here is that similar shapes result from enlargements.